Good day students, I am Somasundaram from Bharathidhasanar Matriculation Higher Secondary School, Arakkonam. We are seeing a series of NEET problems. In our previous video, we have discussed about basic concepts of chemistry and some of the problems we discussed. Today, we are going to discuss redox reactions. I am going to explain the basic concepts required to solve redox reaction related problems today. What is a redox reaction? See, what is a chemical reaction? First, we should know what is a chemical reaction. In a chemical reaction, electrons are moving from one compound to another, and especially there is a bond breaking and then a new bond is formed. So, a redox reaction is a very peculiar type of reaction. Here also we can see the movement of electron from one compound to another compound. See, why it is called as redox reaction? The name itself implies that the redox reaction is a combination of two reactions. One is oxidation, another one is reduction. So that is why it is called as redox. Okay, RED refers reduction and oxidation, OX refers oxidation. So if you want to know about redox reaction, we must understand what is oxidation and what is reduction. So first, the modern concept of oxidation. Previously, there were so many methodologies to understand oxidation reactions, but the modern concept is a very specific one which explains all kind of oxidation reactions. What is it? The reaction in which an element or an atom or an ion or a molecule loses electrons is called oxidation. It may lose one electron or more electron. Anyway, loss of electron is known as oxidation. Oxidation. What is reduction? See, reduction, the reaction in which an element or ion or a molecule may gain some electron during the whole reaction. So here electrons are gained. That is why the reaction is called as reduction reaction. So gaining of electron is known as reduction. Accepting electron, that is another word. Accepting electron also known as reduction. And see, during a redox reaction, you may see some of the ions are not changing their oxidation number. They are as it is in the whole process. Those kind of ions or molecules are called as spectator ions. See, in a balanced chemical reaction, you can see these kind of spectator ions, but we can remove it. I will give you an example. See here, zinc is oxidized into Zn2+, whereas hydrogen, H+ ion is reduced into hydrogen gas. During this process, chlorine, Cl- is not changing its oxidation state. Both the time it is maintaining the oxidation state. That is why we are calling them as a spectator ion. What is a reducing agent? Say, during a oxidation process, a compound may lose electron. While on losing the electron, another atom or another compound will be getting the same electron. So the compound which is undergoing oxidation is alternatively known as reducing agent. What about oxidizing agent? The oxidizing agent, when it undergoes reduction process, during the reduction process, it accepts electron by the loss of another compound. So indirectly it oxidizes another compound. That is why the element which is undergoing reduction is known as oxidizing agent. See, there are so many types of redox reactions are possible. One is direct and indirect redox reaction. What is a direct redox reaction? If a reduction and oxidation process are taken place in a single vessel, it is known as a direct redox reaction. What about the indirect redox reaction? See, in indirect redox reaction, reduction is happening in a separate vessel, whereas oxidation happening in a very different vessel. So, can we give an example? Yes, battery. In battery, oxidation and reductions are taking place in a different vessel. During this process, from oxidation side to reduction side, electrons are moved using a wire. So, when we place a device inside or in between the anode and cathode, or else the oxidation and reduction process, the device is working. So that is an example for battery. The next type is intermolecular and intramolecular redox reaction. What is intermolecular? Two different compounds are undergoing oxidation and reduction is known as intermolecular redox reaction. What about intramolecular redox reaction? Within a molecule, a reduction as well as oxidation may happen. Those kind of reactions are known as intramolecular redox reaction. Very, very particular, and also it doesn't occur regularly. It is very occasional one. So I will give you an example. When we use ammonium dichromate on reduction or on heating, it forms nitrogen and chromic oxide. Okay. So here in ammonium the oxidation state of nitrogen is -3, whereas in nitrogen is a element and it is in molecular form, homoatomic molecule. So the oxidation state is 0. So here nitrogen is losing 3 electrons, that means undergoing oxidation, whereas chromium's oxidation in dichromate is +6, whereas in Cr2O3 the oxidation state of chromium is +3. By the acceptance of 3 electron, it is becoming +3 oxidation state to +6 oxidation state to +3. So it is a reduction reaction, disproportionation reaction. See, most of the time in NEET they are asking disproportionation reaction. So now we will discuss what is a disproportionation reaction. I will give you an example. This is an example for disproportionation reaction. See, hydrogen peroxide, it is a very unstable compound. When it is heated or in presence of a catalyst, it will convert it into water and oxygen. See, during this process, what is the oxidation state of hydrogen peroxide? Yes, obviously it is -1. The oxidation state of oxygen is -1. The same O-1 is undergoing oxidation as well as reduction. So both of the processes are taking place in only one compound. That is why these kind of reactions are called as disproportionation reaction. See here, oxygen -1 charge, whereas in H2O the oxidation number is -2. Whereas in O2 is a homoatomic molecule, so the oxidation state is 0. See, here -1 is converted into -2. That means 1 electron is gained. That is a reduction reaction. Whereas when the conversion is into O2 molecule, the oxidation occurs because it is losing 1 electron. So oxidation and reduction occurs in a single compound. So it is known as disproportionation reaction. I will give you another example for disproportionation reaction. That is conversion of phosphorus. See, when we introduce phosphorus with a sodium hydroxide in presence of base, yes, it gives sodium dihydrogen phosphate and phosphine. These are all the two molecules are formed with phosphorus. See here, phosphorus is giving sodium dihydrogen phosphate, whereas its oxidation state is +1, and here in phosphine the oxidation state is -3. So what is happening here? From 0 to +1, yes, in sodium dihydrogen phosphate the oxidation state of phosphorus is +1. 0 to +1, that is losing electron, so it is undergoing oxidation, whereas in phosphine the phosphorus carries -3 charge. Here phosphorus is gaining 3 more electron, so it is reduction reaction. So both are happening for single compound, that is why it is called as disproportionation reaction. Whereas see the reaction here, the ammonium nitrate, here there are 2 nitrogens are available. One is ammonium ion, another one is nitrate ion. I will write the oxidation state of ammonium nitrate. Both are different nitrogen. Ammonium NH4 plus, which carries positive charge, whereas in NO2 the total charge is -1. This is +1. See, when you calculate the oxidation number of nitrogen here, it is becoming actually -3. Oxidation state of nitrogen in ammonia is -3. whereas in nitrite that is plus 3. So we are having two different oxidation state here, but both of them are converted into nitrogen gas. See here the oxidation state of nitrogen, yeah, it is a homoatomic molecule, so it is 0. Now see the ammonium, in ammonium nitrogen minus 3 converted into 0 by losing 3 electron, whereas in nitrite, yeah, it is also converted into nitrogen molecule. Here it is accepting 3 electron. Both oxidation and reduction occurs and it gives only one compound. So it is actually a reverse reaction of disproportionation reaction. So that these kind of reactions are called as disproportionation reaction. That is a reverse kind of reaction of disproportionation reaction. Next, oxidation number. What is an oxidation number? Oxidation number is actually a state of an element or compound or ion. Mostly if you take a molecule, in that molecule there will be more number of elements or 2 or more elements are possible. Okay, if you find out the oxidation state of an element is known as oxidation number. That is actually a charge. It may be a positive charge or it may be a negative charge. More useful for covalent molecules. We know that ionic molecule carries some charge. So we can easily find out the charge for an ionic compound, but it is difficult to find out the charge of the covalent molecules. Okay. So there are certain rules available to find out the oxidation number of an element. What are they? See, for finding out the oxidation number of various elements present in a compound, we must know what are the non-oxidation states. First one. The first rule is all the free elements and homoatomic molecules are carrying 0 charge. What is the example? I will give you iron. If you take iron atom and hydrogen molecule, nitrogen molecule, copper atom, nickel atom, see these are all free atoms and this is homodiatomic molecules. Yeah, homo triatomic or homo tetraatomic molecules also 0 state. See example P4, phosphorus 4. They are all carrying 0 oxidation state. That is equal to 0. And then the second one. What about the specific oxidation number of alkali and alkaline earth metal? What is alkali metal? First group elements. First group element, they carries always +1 charge. +1 charge. What are the example? Sodium, potassium, lithium, rubidium, cesium. Yes, they are all alkali metal. The next one is alkaline earth metal. They are called as second group elements. Second group elements. See, their oxidation state is always +2. They doesn't show any other oxidation state. Okay, what are the examples? It starts from beryllium, magnesium, calcium, strontium, barium. These are all the examples for alkaline earth metal. And then what about the halogens? Third one, halogens. In halogens, fluorine is the only one element which carries -1 charge. What about other elements? What are the other elements available in halogen? Chlorine, bromine, iodine. See, these elements, yeah, can also show -1 as well as +1, +3, +5 and +7. So these are all the other valencies or oxidation number also possible for chlorine, bromine, iodine, whereas fluorine doesn't show these kind of positive oxidation states, only the negative oxidation state, that is -1. Next one. Hydrogen. The fourth rule is for hydrogen. Hydrogen can show two valencies, oxidation state. One is -1, another one is +1. -1 as well as +1. What about -1? It shows in the form of hydride. Hydride. When it forms hydride, when it makes a bond with a metal, example sodium hydride, NaH. So, when you see hydrogen with a metal, the hydrogen always carries -1 charge. What about +1 charge? Yes, it is also possible. When hydrogen is make a bond with a non-metal, it forms positive +1 charge. I will give you an example, that is HCl, H2SO4. See, in these compounds, hydrogen is attached with the non-metal, so it carries +1 charge. So, when you see hydrogen with the non-metal, you can easily find out the oxidation state as +1. And then the fifth one, the D block elements. See, D block contains more of the metals. D block, mostly metals. They show variable oxidation state. So here it is the difficult part where we find out the oxidation number of D block elements. So how can we find out these D block elements? Yeah, see, most of the time, every time, if you find out the algebraic sum of the oxidation state of the every element present in a compound, it is always neutral, 0. If you take ionic compound, that is different. Okay, if you take a neutral compound, the total oxidation state of each and every element present in a molecule will be always 0. So using that representation, using that definition, we can identify the oxidation state of D block elements also, because it can show variable valencies. I will give you an example, that is manganese. Manganese, it is a D block element. It can show how many oxidation numbers? +1, +2, yeah, +3, +4, +5, +6, and finally +7. See, +1 to +7, 7 different oxidation states can be shown by manganese atom. So that is why we have to find out the oxidation state of an element in a compound. So now we will discuss some of the difficult molecules and how to find out the oxidation state of that molecule. See, first one is Carros acid, that is H2SO5. It is alternatively known as persulfuric acid. Here we are going to find out the oxidation state of sulfur atom. Sulfur. See, first by usual method we are going to find out the oxidation state by the algebraic sum. How many hydrogens are there? 2 hydrogens. So 2. And each hydrogen carries +1 charge. Why? The hydrogen is attached with a non-metal oxygen. So 2 into +1. As I said, algebraic sum. Plus sulfur. Yeah, only one sulfur is there. Now keep the oxidation number of sulfur as X, because we don't know the value, X, plus how many oxygens are there? 5 oxygens, 5 into -2, that is equal to 0. Now 2 plus 1, 2, 5 into -2, that is 10, plus 2 and -10, the value is -8. So X minus 8, that is equal to 0. So X is equal to +8. Like that you will get the value. That is not correct. Actually it is a wrong value. Why it is a wrong value? So first of all, we must know what is the structure of the molecule. See here, This is the structure of the molecule, hydrogen and persulfuric acid. See here, we can see 2 peroxide bond. So that then only we can calculate. So if you want to find out the oxidation state of sulfur here, you must be knowing the structure of the Carros acid. So what is the structure? Here it is available. So now we can calculate the oxidation state of sulfur. So how many hydrogen? 2 hydrogen. Obviously it is 2 into plus 1 plus sulfur, keep it as X, plus how many oxygens are carrying minus 2? Only 3 oxygen, not 4. So 1, 2, 3. These 3 oxygens are carrying minus 2 charge. So 3 into minus 2 plus 2 more oxygens are left. Both are carrying minus 1 charge. So 2 into minus 1. Now see, that is equal to 0 because it is a neutral molecule. See, plus 2 and minus 2 can be cancelled. What are the remaining values? X minus 6. So X minus 6, that is equal to 0. What about X then? X is equal to plus 6. So this is the oxidation state of sulfur in Carros acid. The next one, oxidation number of sulfur in H2S2O8, which is generally called as Marshall's acid. Here also you must be knowing the structure. Without the structure you can't find out the oxidation state of sulfur. So what is the structure? See, this is the structure of peroxide Marshall acid. Here you can clearly see there are 2 peroxide bonds available. So now how to calculate the oxidation state of sulfur? The same usual value, as usual. How many hydrogens are there? 2 hydrogen, 2 into plus 1. Each carries plus 1 charge, yes. Plus, how many sulfurs are there? 2 sulfur. So consider 2, the oxidation state of sulfur is X. So 2X. Plus, see, 1, 2, 3, 4, 5, 6. 6 oxygens are carrying minus 2 charge. So 6 into minus 2. Plus, how many oxygens are carrying minus 1 charge? There are 2 oxygens, a single peroxide. So 2 into minus 1. What about the total charge? Yeah, it is a neutral molecule. So that is 0. 0. Now again also 2 and 2 can be cancelled out. Plus 2 and minus 2 are there. And 2x minus 12. 6 into minus 2, that is minus 12. That is equal to 0. What about 2x then? 2x is equal to plus 2. So x is equal to plus 6. Okay. So each of the sulfur atom is carrying plus 6 oxygen state. Both plus 6, here also plus 6. That's it. Next compound, oxidation number of chromium in CrO5. So first, what is the structure? Perchromate. Here also you can see 4 peroxide oxygens are available and only 1 oxide is available. So if you calculate it in our usual method, it will give plus 10 as the oxidation state for chromium. That is usually wrong, because chromium can show the highest oxidation state as plus 6, not beyond that. Okay. So now chromium. So consider the oxidation state of chromium as X. Plus only 1 oxide is there, that is minus 2 charge, minus 2 plus how many peroxide oxygens are there? 4. So 4 into minus 1, that is equal to 0. So X minus 2 minus 4, that is equal to 0. So x minus 6, minus 2 and minus 4 forms minus 6, that is equal to 0. So x is equal to plus 6. So this is the oxidation state of chromium. Okay, so you can't calculate it by usual methodology. Dear students, today we discussed about redox reactions and we found how to calculate the oxidation number of elements present in a molecule, and I have shown different kind of molecules and we have found the values also. Okay, so if you have any doubt, you can contact me through mail and we are very much delighted to help you. Thank you.